Hello, welcome back. I hope you are enjoying the lectures of carbohydrates which we are discussing from past several days. And already I have uploaded 3 videos which are discussing the carbohydrates, various elements of carbohydrates. In this video tutorial, we will be discussing the function of biological significance of biological significance of ribose and galactose. Glucose we have discussed it last time. Ribose and galactose. First of all, if we see what is the significance of ribose, let's take ribose first. The ribose was discovered by Levine. It was discovered by Levine in the year 1909. 1909 it was discovered by Levine. And this ribose is a pentose sugar. It is a pentose sugar. It is made up of 5 carbons. We already know it. Also, this ribose is stable in furanosic form. We have already discussed this thing. Because C5 and C6 these carbohydrates, monosaccharides, are stable in ring structures, and the possible ring structures are pyranosic and furanosic. This is stable in furanosic form. If we see the structure, when we see the structure of this ribose, the structure, it is basically made up of, it is the formula is C5 H10O5, right? This is ribose. And ribose we can write this way: 1, 2, 3, 4, and 5. Here the functional group of ribose, since it is stable in aldehydic form, it is we can say it is CHO. Here it is OH. Here it is OH. Here it is OH. And it will be CH2 and OH. And here it is H, H, H. We can call it as D-ribose, right? D-ribose. And the ring form, which is possible, the ring form structure of the ribose is basically showing its stability in furanosic form. And you know, furanosic ring is a ring which is pentagonal, right? Which is pentagonal. That means I have to draw it like this. And here it has a hydroxyl group here, hydroxyl group here, hydroxyl group here, and here it has CH2OH, CH2OH. The rest of the places, for the rest of the places, we have to incorporate H, right? This is carbon 1, this is carbon 2, 3, 4, and this is 5. This is the ribose. I can say this is alpha D ribose. Alpha D ribose. Why alpha? Because the hydroxyl group is on the lower side. Anomeric carbon, the hydroxyl group which is present at the anomeric carbon is located on the lower side. And why D? It rotates the plane polarizer light towards the right. Most of the sugars are dextrorotatory. That's why D. And ribose, you know, because it's a pentose sugar. Now, there is a difference between ribose and deoxyribose. Deoxyribose can be derived from the ribose by simply eliminating one oxygen atom at position number 2. Here we have position number 2. If we eliminate this oxygen atom, instead of ribose, this becomes deoxyribose. So this is our deoxyribose. So deoxyribose can be simply derived from ribose, right? This is the structure. Fine. Then, what is the importance of this ribose? Ribose is a constituent of ATP, adenosine triphosphate, adenosine diphosphate, adenosine monophosphate, guanosine triphosphate, guanosine monophosphate, guanosine diphosphate, and so many things. So these compounds, ATP is an energy-rich compound occurring everywhere in the body as the source of energy. And this ATP, if we will see, or this ADP, AMP, GTP, GMP, they have the constituent, they have one of the important constituent, that is ribose. And if we see, for example, when we have ribose, this is ribose, this is our ribose. This ribose is attached to, for example, adenine. When I will say ATP, this adenosine triphosphate, the adenine is attached to the sugar, and the sugar is ribose. The sugar is ribose. Here we have one is adenine, second sugar. In this sugar we have CH2OH. Here there may be phosphates. There may be phosphates. And in adenosine triphosphate we have three phosphates. So we have three phosphates. There are three things. One is the adenine and second is the ribose. The nitrogenous base along with the sugar is known as adenosine. If it is guanine here, it is guanosine. If it is cytosine, cytosine, right? So the combination of the ribose, the combination of the sugar and the nitrogenous base forms adenosine, guanosine. So this is adenosine, adenosine 1 and 2 makes adenosine, and these three phosphates make triphosphates. Adenosine triphosphate. When I go for diphosphate, I have to remove one phosphate. In short, we can say this ribose is forming the nucleosides. What is a nucleoside? Nucleosides. Nucleoside contains two things. This is the nitrogenous base. It is made up of nitrogenous base and it is made up of sugar. So whenever you have the combination of nitrogenous base and sugar, we call it as a nucleoside, right? And polyphosphorylated. Suppose polyphosphorylated nucleosides. Polyphosphorylated nucleosides. Now I will add up the phosphorus groups to this nucleoside. Polyphosphorylated, maybe 1, 2 and many. Polyphosphorylated nucleosides are known as nucleotides. It becomes a nucleotide, right? This becomes a nucleotide. So ribose is a component of ATP, ADP, AMP and other things. And one more thing about ribose is that ribose is used, it is utilized for the synthesis of riboflavin. It is utilized for the synthesis of riboflavin. Riboflavin is known as vitamin B2. So it is one more function is it is utilized for the synthesis of riboflavin, and it can be used to increase the endurance and athletic performances. Because this has some link with the ATP. This has a link which is attached to the energy-rich compounds, formation of energy-rich compounds like ATP, GTP, right? So once we can say this ribose can be used for increasing the athletic performance and increasing the muscular energy, for increasing the endurance of supporting activity. So endurance, for endurance, it can be used. And we have a disorder which is known as chronic fatigue syndrome. Chronic fatigue syndrome. We can give this ribose in chronic fatigue syndrome. That's all about ribose. Now we will go to another thing which we call as galactose. This is the significance of ribose. Now we will go to the galactose. Galactose again is a monosaccharide. It is a monosaccharide, very important monosaccharide. After ribose we have galactose. The significance. First thing, the galactose is a hexose. It is a hexose. The formula is C6H12O6. And the galactose has an open chain structure like this 1, 2, 3, 4, 5 and 6. Here it is CH2OH. Here it is CHO. 1, 2, 3, 1, 2, 3, 1, 2, 3, and 4. This way I can write galactose. Here it is H, here it is H, here it is H. As compared to glucose, the difference lies at carbon number 4. This is the carbon number 4. This is the difference. Here OH is on this side and the glucose has OH on that side. Right? The difference lies at carbon number 4. Okay. This galactose is stable in pyranosic ring form. It is stable in pyranosic ring form. This is the pyranosic ring form. Here we have, this is the pyranosic ring form 1, 2, 3, 4, 5, and 6. It is here CH2OH. Here it is OH, then it is alpha, right? So we can substitute the other OH groups as well. This is our pyranosic ring structure of galactose. Now, this galactose has a significance. Number second, the galactose has a significance. We see galactose as the component, as a component of antigens, which are present on the surface of RBCs, and are representing ABO blood group. So we know for blood group A we have antigen A present on the surface of RBC, and for blood group B we have antigen B present on the surface of RBC. For AB we have A and B both. So these antigens which are present on the surface of RBCs have galactose as a constituent. They contain galactose as a constituent. So, so far as this blood group A is concerned, there are two units, or we can say there are two monomeric units of galactose, and for B there are 3 monomeric units of galactose. This galactose is also known as brain sugar. We call it as brain sugar because it has a role in the development of brain during infant life. It has some role for the development of brain at the stage of infancy. At the stage of childhood, it is responsible for the development of brain. And this galactose has some role to maintain. It has some role to maintain the gut microflora. It has some role to maintain the gut microflora. Our gut contains microflora. That's also very essential. And this gut flora is maintained by the sugar, that's galactose. And one more thing, this galactose may have some applicability in kidney functioning. It has some role in kidney functioning because this galactose is used for treating chronic focal glomerulosclerosis. Chronic focal glomerulosclerosis. So it has some applicability in the kidney functioning. And one more thing, galactose is never present alone. You will always find it in association with something. For example, you will find galactose as a constituent of lactose. Lactose is a milk sugar which is converted into glucose and galactose, right? So it's a constituent. It is not present. It is not usually seen as an individual. You will find galactose always mixing with something else. It is present in combinations. For example, it may be found in the lactose, and it may be found in the agar-agar. You will find galactose in agar-agar. You may find it as a constituent of glycoproteins, and you will also find it as a constituent of glycolipids. It is a constituent of lactose, agar-agar, glycoproteins, and glycolipids. That's all about galactose. We'll be discussing other things as well. Thank you very much for watching.